Good morning. I'm Dela Cruz and I'm your reporter for today. And we're gonna talk about thermoelectric generator or TEG. So what is TEG? Thermoelectric generator is a solid state device that converts heat flux or temperature differences directly into electrical energy through a phenomenon called the Seebeck effect. Take note about Seebeck effect because we're gonna talk about it later. Thermoelectric module. At the heart of a TEG is the thermoelectric module, in short TEM, which we also call a TEG module. A TEG generator is a device utilizing one or more TEG modules as the primary components, followed by a cooling system. The cooling system can be either passive air, active air, or hydronic. These components are then fabricated into an assembly to function as one unit, called the thermoelectric generator. Now, thermoelectric system. A TEG system incorporates other hardware into a TEG, like water pumps, electronics, and firmware. This helps prioritize power and keep the system cool. A good example of a TEG system is the TEG Pro 100 watts TEG water-cooled system that will cycle water from a baseboard hot water heating system through a water-cooled TEG. As you can see at the right, there is an example of a thermoelectric system functioning. How are TEG modules made? Construction of TEG power module consists of pairs of p-type and n-type semiconductors materials with a high thermoelectric coefficient. Although many alloys can be used, bismuth telluride is the most common material used today. This material is sliced into small blocks. One forms the p-type conductor and the other the n-type conductor. Each pair forms a thermoelectric couple or TEC, and these thermocouples are most often connected electrically, forming an array of multiple thermocouples, or in short thermopile. Unlike solder used in the construction of TEGs, the thermoelectric generator modules often require solders that reflow well in excess of 400 degrees Celsius. Most thermoelectric generator module manufacturing companies use many thermoelectric couples that are sandwiched between two pieces of non-electrically conductive materials. It is also necessary for this material to be thermally conductive to ensure a good heat transfer. Usually, two thin ceramic wafers are used to form what is called a thermoelectric module. Each module can contain dozens of pairs of thermoelectric couples and be called thermoelectric generator modules, TEG modules, and sometimes Peltier or Seebeck modules, which simply denotes whether they are being used to generate electricity or produce heat or cold. Functionally, there is no difference between the two. They both are capable of producing heat and cold or generating electricity, depending on whether heat is applied or an electrical current. Why is there a need for thermoelectric generator power? Electricity is a necessity. If you've ever had to suffer through an extended power outage, you'd know what it is like to lose all the food in your refrigerator. If you live in a cold climate, your house was cold because you have no heat, as the majority of heating systems required power to run. Millions of folks have been in this position when a winter storm knocked out power over large areas. Solar panels are a great renewable energy source, but they only produce power in the daytime. Their daily output is significantly reduced during the shorter days in the winter months. Using TEG power generators in cold climates, in conjunction with solar, can provide all of your home's energy needs. So, what are the Advantages and disadvantages of the TEGs. Advantages is 1. It is environmentally friendly. 2. It recycles wasted energy. 3. And its scalability, meaning the device can be applied to any size heat source from a water heater to a manufacturer's equipment. 4. It's a reliable source of energy. And it's 5. Lowers production cost, which is good. Disadvantages. Number 1, low energy conversion efficiency rate. 2, slow technology progression. 3, we only have limited applications to use. 4, requires relatively constant heat source. 5, it's lack of customer industry education about thermoelectric generators, and without that, there will be no one to support that idea. So, moving on, the Seebeck effect. The Seebeck effect produces an electric current when dissimilar metals are exposed to a variance in temperature. Seebeck effect applications are the found of thermoelectric generators or Seebeck generators which convert heat into energy. The man behind Seebeck effect is Thomas Johann Seebeck. He is a Baltic German physicist who in 1822 observed a relationship between heat and magnetism. Later, in 1823, Ørsted called this phenomena thermoelectric effect. The Seebeck effect. Thomas Johann Seebeck discovered that a temperature difference between two different metals produces a voltage difference. You'll see two different electric conductors called p-type and n-type. What happens is the heated electrons flow towards the cooler ones. See at the right sides the positive negative arrows pointing down. And when this pair is connected through an electric circuit, direct current flows through that circuit. Seebeck generators. The voltage produced by TEGs or Seebeck generators is proportional to the temperature distance crossed between the two metal junctions. As you can see at the right side, it's the Seebeck generators chart. The Seebeck effect versus Peltier effect. The Peltier effect is the reverse phenomenon. Instead of applying heat differential, electrical current is passed through the materials and as a result, heating or cooling produced. The Seebeck effect inside a TEG module. The voltages produced from the Seebeck effect are small and depend on both the material used and temperature difference. However, inside a TEG module, there are multiple p-type and n-type pairs that can be connected in series to increase the output voltage or in parallel to increase the current. In the image to the right, you can see the p-type and n-type materials connected in series by the yellow line. That's all. Thank you for listening.